Hello class, and thank you for watching the first part to 5.4, dividing polynomials. We're going to focus on using long division and or synthetic division to divide polynomials of degree 3. Let's review how to divide, again, just monomials. Now, to divide a monomial, simply requires us to divide the coefficients of the monomial like normally and subtract the exponents to our variable. So if I'm dividing, let's say, x to the fourth by x to the second, since the coefficients are both 1 right there, 1 divided by 1 is going to become 1, and x to the fourth divided by x to the second is going to be the difference between those two values. So we end up with 1x to the second power. Similarly enough, here we'll do the exact same thing. So this will simplify to x to the second power, and again 1 because we're dividing 1 by 1. And since 3 minus 1 is 2, x to the second power. Now for this example right here, let me rewrite this in this format. We have 6x to the fifth power divided by 2x to the second. So we'll divide again the coefficients like normal. So that will be 6 divided by 2, which is a total of 3. And our exponent on the variable x is going to be the difference between these two values. So 5 minus 2, that's 3. And then the same thing with the last example. So this one right here, 9 divided by 3 is 3. And to divide our variables, x to the fourth divided by x to the first power, we would get the difference between 4 and 1, which is 3. So this would give us a quotient of 3x to the third power. So let's look at an example of how we do long division with polynomials. Now here I have a template which I have included on the last page of our notes for this lesson right here, and I just copied and pasted it right there. In class, I'll provide you with a template right here for you to guide yourself, and just so you have a guide on how to set this up. Well, with long division, just like with any division, our dividend, which is this one here, okay, our dividend goes inside our division box, and our divisor goes on the outside. So this template right here is just so we can focus on the values and the numbers. So we're going to write in the number 8x to the third, 76x to the second, 52x, and 8 on the fourth and final term there. Now our divisor is x plus 4. So we're going to put that on the outside, and right here in our template, that would have 8 in that box and 4 on that box right there. Okay. Now, the way that long division works is the same for polynomials is the same as with normal regular long division. We begin by figuring out how many times can our divisor go into our dividend. But with polynomials, it's a lot easier because all we have to do is focus on the leading term of both the dividend and the divisor. So we begin by simply dividing 8 by 8. And 8 divided by 8 equals to 1. So that's going to be the first term in our quotient. So we're going to put the number 1 up there. Now, just like with normal long division, what we do with this quotient is to multiply this quotient with our divisor. So we're going to multiply this one term with both of these values here. So we'll start by multiplying 1 with 8, which is 8, and multiplying 1 with 4, which is positive 4. And then the third and final step for this round here is to subtract. Now, because we're subtracting a binomial from a polynomial here, it's more efficient and equivalent to simply change the sign to these two bottom terms here and then use our addition rules of integers. So adding a positive 8 with a negative 8 is equal to 0, hence why the template doesn't have any boxes right there, because that term should always be 0. And adding a positive 76 with a negative 4 by our integers rules of addition will subtract those two numbers, giving us a value of 72. And positive 72, because the larger value 72 is positive, so that gives us a positive value. as the arrows indicate right here in our template, we're going to bring down the 52 and bring down the 8. So we now have this term. So now this is going to be divided by 8x plus 4. So we then just follow again the procedure all over again and do the exact same 3 steps now with this new leading coefficient and of course the original one that I had, the 8x plus 4, which I just erased. If it makes it more practical, you can write it down here and treat this thing as its own. I just use the same one right there. It's already written on top. So I'm just going to continue using that one right there. And again, we only have to worry about dividing the 72 by 8. And since 72 divided by 8 is 9, that number is going to go right there. Now, what we do with this 9 is we're now going to get this 9 and multiply it with the 8 and the 4. So 9 times 8. Sorry there, I got distracted by the little alert there. 9 times 8 is 72 and 9 times 4 is 36. So we're going to write those in the following 2 boxes underneath right here. So like I said, 9 times 8 is 72, so we'll write that there. And 9 times 4 is 36, and we'll write that here. Okay. Now, before we try to subtract them or again try to do anything, we're going to get this opposite signs to those values and we'll add them, which would be the equivalency of subtracting these 2 numbers from these 2 numbers. So following our addition rules of integers, opposite numbers is going to become 0, and 52 plus a negative 36 will subtract those, giving us a difference of 16. Bring down the 8, and then we do the exact same 3 steps, 1/3 and final time. So our 16 will be divided by our 8, which is going to give us a total quotient of 2, and we'll write that up there. So I got 16, and I divided it by 8, which gave us our final value of 2. So now we're going to get that's 2, and we're going to multiply it with both of these values. Not just the 8, but with the 4 as well. That's what's different when we go down, that we multiply it by both quantities. So 8 times 2, that's 16, and 8 times 4 is 8. Let's switch the signs to these 2 terms and add downwards. This again is automatically 0. And there should be a box right here because this number right here is very important. I just didn't have it on the template. I made a mistake of not including that there. And that value is going to be 0. Okay? So that number right here is very important because this last number is our remainder. And in this example, the remainder is equal to 0. So we don't have to worry about that in this example. So where's our answer? Well, our answer again is our quotient, which is this value up here. So our answer is going to be 1x to the second power plus 9x plus 2. One x to the second power plus 9x plus 2. And that is our quotient. So let's look at this example. I'm not going to include the template this time. And I'm just going to do it without the template and set it up again the exact same way. So our division box, and we're going to write 7x to the third power plus 6x to the second minus 15x plus 2. And we're going to have 7x and negative 1 there. Okay. Now our answer is going to look something like this. We're going to have x to the second plus some number x and then plus some constant. So we need to fill in and identify what these coefficients are going to be. What is this coefficient going to be? What is this one right here going to be? And what is the constant right here going to be? Now the solution is always going to be in this format of x squared, x, and constant, because we start off with x to the third power and we're dividing it again by a binomial of degree 1, a linear factor. Okay, well, not necessarily a factor, but a linear binomial. If this was 2, then these would be decreasing in increments of 2. But because this is 1, they're going to decrease in increments of 1. So 2, 1, and then x to the 0 power. So it's always going to, the format's going to always be the same. So just simply figuring out what these numbers are going to be. So we start as we started last time and simply focusing on the leading term. And all we do, and I should color coordinate these, let me do it in blue, to figure out what the first blue number is to divide those. So 7 divided by 7 is 1. So the first number is going to be 1. We'll now multiply the 1 with both of these terms. So this entire thing, 1 times all of this, is going to stay the same, and we're going to write it underneath. So we're going to have 7 x to the third power minus 1x to the second. We're going to switch the signs. So I'm going to change this to a negative value, change this to a positive value, and then just simply use our addition rules. So this is going to become 0, so this cancels out, and this is 7. So 7x to the second power. Let's bring down the next two terms. And I deleted that because I now want to figure out what the red number is. So what I'm going to do to get the red number is now divide this term here in our new part of the quotient, new part of the dividend, with this term right there. So we get this new dividend, look at the first term to this new dividend, and divide it again by the first term of our divisor. So 7 divided by 7 is 1. So we now have 1x to the first power. We're now going to multiply this second one with our divisor, which is going to keep us the same value, 7x to the second power minus 1. And we're going to change the sign to those values. So this is going to change to a negative, this is going to change to a positive. So this again becomes 0. And a negative 15 plus a positive 1, different signs, so you subtract. I forgot to put the x right there. And it will be negative 14 since the 15 is the bigger value. And it's negative. Let's bring down the 2. And to get the third and final value right there, we're now going to get this leading term on this new dividend. And divide it again by the leading term in our divisor. So negative 14 divided by a positive 7, that's a negative 2. So negative 2 times 7 is negative 14x, and negative 2 times negative 1 is positive 2. We switch the signs, so this is going to become positive, this is going to become negative, and adding a negative 14 and positive 14 is 0, and adding a positive 2 and a negative 2 is also 0, which is our remainder. So our answer here is 1x squared plus 1x plus negative 2, or simply x squared plus x minus 2. So there is your quotient. Okay, for this next example on the next page, I put the template back on to the example because of a missing term that we have here. So our divisor is 2x minus 2. So again, this goes in, this goes out. And our divisor is 2x minus 2. So I'm going to put 2x minus 2 there. And our dividend is 12x to the third power, so 12x to the third power minus 4x. And then we have the constant of 8. So that's going to be this last fourth term there. Now notice that we do not have a value that we're multiplying our coefficient with x. And the reason for that, because in the divisor, that term is 0. So we have 0x to the first power minus the constant. So our linear term is 0, and hence why it's not written. Anytime we have a term that has a coefficient of 0, that term is ignored and simply skipped in or written again in the polynomial. Which is the reason why I wanted to use again this template, so you could see again that we still need to input that number in our dividend, because we need to keep account for every single term, even though it's not written in the dividend. So now let's figure out what the quotient is. So we'll do the exact same thing. Start by looking at the leading coefficient of our dividend by the leading coefficient of our divisor and divide those two numbers. So 12 divided by 2, well, that's simply 6. And we'll multiply that 6 with both of these values to get this line right there. So 6 times 2 is 12, and 6 times negative 2 is negative 12. We will switch those two signs. So this becomes positive, this becomes negative, and these are opposite, so they become 0. And since these values are opposite, negative 6 plus a 12, that's a total of negative 8. I'm sorry, positive 8, not negative 8. And we'll bring down the next two terms. So we'll have to bring down the 0 and bring down the negative 8. Now with this being the new line, this is our new dividend, we'll focus on the first term and divide that by 2. So 8 divided by 2 is 4, and that goes in that new line there. So 4 times 2 is 8. 4 times negative 2 is negative 8. We'll switch the signs, change this to a negative, change this to a positive. This becomes 0. They're opposite terms. And 0 plus 8 is 8. Bring down the negative 8. And now we have our third and final term where we're going to look at this as the new dividend and divide just the first term, 8, by the first term of our divisor. So 8 divided by 8 is a total of 2. I'm sorry, 4. What am I saying? 4. So now 4 times 2 is 8, and 4 times negative 2 is negative 8. We switch the signs. And like I mentioned earlier on this template, I should have technically put a box in right there, because that box right there is our remainder. And on this example, it makes no difference because the remainder ends up being 0. So our quotient is again this part up there, which is 6x to the second plus 4x plus 4. So for our next example, let's set this up. We're dividing by 7x minus 1. So that's going to go here. 7x minus 1 goes there. And our dividend is 7x to the third power minus 29x to the second minus 45x and plus 10. So this 7 gets divided by that. And that's going to be the number that we write there. So 7 divided by 7 is 1. So we have 1x to the second. Now 7 times the 1 is going to give us 7, which again is always going to be the case that these two numbers are going to start by looking the same, because it makes sense, because since you divide 7 by 7 to get that value, then that would mean that if I get 1 and multiply with 7, it should match to that number there. Now the key thing is this next number right there, because we need this number to figure out what the next line, what the starting number is to the next line. And that's the result of multiplying 1 and negative 1. So that is a total of negative 1. Now we'll switch the signs, and then we follow our addition rules of integers. So a negative 29 plus a positive 1, different signs, so we would subtract. and keep the sign of the larger value. And now we can bring down the other two terms, and we're ready to start over. So to figure out now the second number here, we're going to get negative 28 and divide it by 7, and that's going to go there. Negative 4. Now, the number that goes underneath the negative 45 is the result of multiplying this negative 4 with this negative 1. Again, like last time, this times this will automatically make these two numbers match up. But the key thing is, again, is that number right there. Negative times negative is positive, so we end up with positive 4. Let's switch the signs. And that's a difference of 49, negative 49. And you'll notice that, again, these numbers, when we divide with this leading coefficient, always divides to a whole number. So if you do not get a value that divides correctly and gives you a decimal, then you did obviously something incorrect up here, or maybe up here with the sign when you multiplied it with that. So if I ended up like with 41, because I forgot to maybe switch this value, and I kept this as a positive 4 instead of the negative 4, and I ended up with 41. I know 41 is not the right answer because 41 divided by 7 doesn't equal to an integer. So let me put back my 49, and now let's divide our negative 49 with 7, which is negative 7. And that second number right there is the result, let me zoom out, of multiplying negative 7 and negative 1, which is positive 7. And when we switch our signs, this becomes positive, this becomes negative. And now we end up with a remainder that is not going to be 0. We end up with a remainder of 3. So let me explain how we're going to write that answer now that we end up with a remainder. Well, we write our quotient the same way as before, which was 1x to the second power minus 4x plus negative 7 minus 7. And since our remainder is 3, we write that value as a mixed number, adding the remainder of 3 over the divisor of 7x plus negative 1. So this is how we represent the quotient to this expression, now with a remainder that is not 0. Okay, so let's set this problem up. We're dividing by 2x minus 7. And our dividend, what we're dividing into, is 4x to the third power minus 57x plus 32. So notice that there's no x squared term, no cubic term in this expression right there. That's because, again, the coefficient is 0. So we need to have a placeholder for that value. So we need to put a place 0 right there in using this long division technique. So dividing 4, so let's start and divide 4 by 2, which is 2. And now let's multiply specifically these two values. That's the ones that are interested. And this should always match up. So you could automatically know that this is going to be 4. Okay. So this is going to give us negative 14. Let's switch the signs. So negative and positive. And 0 plus 14 is 14. So let's bring down the negative 57, bring down the positive 32, and I automatically know that this number is going to be 14 when I multiply down. So dividing, so to figure out what the number is up here, I'm going to divide this 14, or this one, doesn't matter, by 2. So 14 divided by 2, that's going to be a total of positive 7. Okay, now this number, again, is the one that we're interested in because we need that number to go on to the next level to figure out what the next value is down here. So we're going to get 7 and multiply it with negative 7, which is negative 49. Now, if you add those two numbers, you're going to get with something that's not going to be divisible by 2 as a result. Well, it will be, but it will be way, way, way too big. It's going to be the wrong value. So we need to change the signs. And now when I do negative 57 and I add it with 49, that's going to be a difference of negative 8. So I know this number is going to end up being negative 8. I'm going to bring down the 32, again, indicated by the arrow. And again, you should automatically picking up on these problems that we've done with all the examples that we've done. Hopefully you picked up on the fact that these numbers are always matching up before I switch the signs. So it's figuring out what this value is right there. Well, we first need to figure out what this number is. So let's get negative 8 and divide it by the 2, which is negative 4. Okay, that's important that you get the sign right. And multiplying that negative 4 with negative 7 is how we get that number, which is going to be a positive value of 28. We switch our signs, and the difference between these two values is 4. So another example where we ended up with a remainder. So just like the previous one, we're going to include the remainder as part of the quotient by simply adding that value over the divisor. So there is your quotient. Now this last example I'm going to go over using long division. I'm not going to use the template. I'm just going to set it up again here by hand. So we have 3x plus 5, our divisor, and in the division box is the dividend, 6x to the third power plus 28x squared plus 9x minus 31. So we begin by dividing 6 by 3. 6 divided by 3 is 2. So that's 2x to the second power. And the reason that, again, which I don't think I explained this, the reason that the exponents on our variable is decreasing by 1, notice that we start off with 3, is because we're dividing by x to the first power. And since we're dividing by x to the first power, that's going to decrease these values by 1. So 3 minus 1 is 2. 2 minus 1 is going to be x to the first. And 1 minus 1 is 0, which is going to be our constant. So I know the second term should be x to the first, and then of course we're going to have a constant at the very end. So let's figure out what the rest of this thing is. So let's continue. So this is going to be 6x, like I said, to the third power. This number that's going to go underneath the 28 right here, that's going to be the product of 5 times 2. So 2 times 5, which is 10. And it's a positive 10, so I'll put plus positive 10x to the second power. We're going to change the sign to these two values, so this is going to become negative, and this is going to become negative. This is 0. And our next line is going to start with 18x to the second power plus 9x minus 31. So now we're going to divide the 18 by 3, which is 6. And 6 times 5 is 30. And we'll switch the signs. Now 9 plus negative 30, that's equal to negative 21x. And we'll bring down the negative 31. Now negative 27 divided by 3, that's a total of negative 7. And negative 7 times positive 5, that's negative 35. Let's switch our signs. And we have a remainder of 4. So our solution here is 2x to the second power plus 6x minus 7 plus a remainder of 4 over 3x plus 5. Okay, now that we've done the examples using long division, now let's talk about synthetic division. Synthetic division is another technique that can be used to divide polynomial functions. However, the catch to using this technique, it only applies in situations where our divisor, the value that we're dividing by, the binomial that we're dividing by, is a linear binomial of the form of x minus some constant c. That constant c could be positive or negative, but we're doing something in that format. So if I was dividing by x squared minus c, then I wouldn't be able to use this technique. Or if I was dividing by 2x minus some constant, then I wouldn't be able to use this technique. So it only works, unfortunately, in this scenario, okay? And it's called synthetic division because we really don't divide it. And no form of division is actually being done, but it does give us the quotient of a division expression of polynomials. So let's jump into it. And I have the steps right here, so you can read along and read them for yourself. But I'll go jump into an example and see how this applies. Okay, so we begin by first filling in these top values right there, okay? And the values that are going to go inside the division box, again, are simply going to be the coefficients of our dividend. So here's our dividend, and our coefficients are 1 x to the third power, 1x to the second, negative 4 x to the first, and our constant is 6. Now, on the outside of which is going to be the divisor, we're only going to focus on the constant because this is in the format of 1x minus negative 3. We're going to focus on this constant and get the opposite of this value, which is negative 3. Because this is in terms of a subtraction problem, x minus a negative 3. The double negatives is the reason why we have a positive. So we're looking for that value right there, which is simpler to understand that you're just simply getting the opposite of that term. So hence negative 3. And again, that's very, very important that you always remember that you're getting the opposite of that. Now, let's look at what the technique is for this, what the procedure is, for this technique of synthetic division. And like I mentioned earlier, there's actual no division at all. So we start by first bringing down the first term, which is the value of 1. And what we're going to do to figure out the next term right here, this term right there, is that we're going to multiply this number with this quantity right there. So we're going to get this negative 3 and multiply it with 1. And that's going to be the number that goes in this box right there, which is negative 3. We're going to simply add going downwards. So 1 will be added with negative 3, and that's the value of negative 2. And then we just simply repeat the process. We're now going to get to this 3 again, multiply it with this second number, and that's how we get the third number in the bottom row. So this is 6, and we're now going to add those two vertical values. So we're going to add going down, which is positive 2. We'll now multiply this negative 3 with 2. And we're going to get this next number, which is negative 6. And our last value is 0. And just like with long division, the last step that we do defines what our remainder is going to be. So this one right here is our remainder. So our remainder is 0. And for the same reason as the previous one, because we're dividing by x to the first power, that means that our quotient is going to divide all of these x's by that 1x, reducing the exponent from 3 to 2 to 1, and then to our constant term. So our answer is going to be 1x to the second power minus 2x to the first, and then plus 2. Let's move on to the next example. And this one we can use synthetic division again because our divisor is in the required format of our our variable x plus some constant c. So we'll write in the values in the box of our dividend. So we have 3x to the third power, we have a 9x to the second power, and then we have a constant of negative 12. Since these places are for these terms, sorry, mistake right here, our constant, negative 12, should be in the last box. Now, since there's no linear term in x to the power of 1, that's because, again, the coefficient is 0, like the prior time that we were missing a term. So we're going to have to put the number 0 in this place value for this situation. Now, on the outside, the number that's going to be written in this box here is going to be the opposite of this value. So let's start our synthetic division by bringing down the 3 and multiplying our -2 with that value, which is -6. So that's going to go there. This adds up to a +3, and we'll multiply now a -2 with a +3 again, and that goes there. That adds up to -6, and now we're going to multiply our -2 with -6, which is +12, and that goes there. Here this adds up with 0, so our last value being a remainder again is 0. So our solution here is 3x to the second power plus 3x to the first minus 6. And obviously again, there's no remainder, so we leave our answer like that. So let's do the last two without the template I provided and just join it ourselves. So we have 1, 4, -12, -20. And on the outside, because this is a -3, is going to be +3. So we bring down the 1. We start by bringing down the 1. And we'll multiply the 3 with 1. And that number will go underneath the 4. So that's going to be 3. Remember, we add these numbers, and this adds up to 7. Now multiplying 3 with now 7, that gives us 21, and that goes underneath the 12. And we'll add those numbers, which is a difference of 9. +9. Now multiplying the 3 and the 9, that's a total of 27. And adding -20 with the +27, that gives us a difference of 7. So we have a remainder this time, and our remainder is 7. So like last time, we'll include the 7 by putting it over our divisor. So here we're going to end up with 1x to the second plus 7x to the first plus 9, and then a remainder of 7 over x minus 3. So let's set this one up again without the provided template, and let's just write this ourselves. So we have 8x to the third power minus 18x to the second. There is no linear term, so we're going to use the number 0 for that, and 6 as our constant. The opposite of -2 is +2, and we are ready to start. So 8, and 2 times 8 is 16. This adds up to -2. 2 times -2 is -4. This adds up to -4, and -4 times 2 is -8, which adding the next two numbers, the last two row, that gives us a total of -2. So we have a remainder of -2. So our solution here is 8x to the second plus -2x, or minus 2x, and then plus -4 or minus 4. Our remainder is -2, so we'll add that -2 over our divisor of x minus 2. Now another way of representing the remainder part, okay, saying that we're adding a -2, we can also simply state that we're subtracting a +2. So we can also write it like this, compared to that. Okay, so adding a -2 is the same thing as subtracting a +2. So this is your quotient with your remainder. Now this concludes this last part, this first part to this section here. And the next video we'll talk about the remainder theorem and the factor theorem and how we can apply that and how we use those two theorems. I hope this video was helpful, and I appreciate you watching. I hope you have a great day. Goodbye.